All right, so today we're going to take a little bit closer look at specific heat calculations and look how they can tie into finding how much energy goes into a phase change for a particular substance. So far in this unit, we have worked with just our simple specific heat calculation. This is what you guys have been doing the past couple of days. So we've been working with the equation for energy equals mc delta T, with C being your specific heat value. Now, if you think back a couple days ago, last week, we worked with, or asked you a question, or what you would think a graph would look like if you started out with ice and you heated it up until it was at the point that it had evaporated, so it was steam. And we've talked about it would end up with a graph that looks something like this. You're going to have a curve or a line going up, a straight horizontal portion, another line going up, another straight horizontal portion, and a line that will go up indefinitely in temperature. And today we are going to talk about why that is. So, when you have that phase change occurring, when you are heating that substance up, it is going to take a lot of energy input to cause that substance to change states, to change phases of matter. So when we are working with phase changes, there's going to be different specific heat values or different heat values you need to be able to plug into an equation to be able to more accurately discover how much energy went into that phase change. Now, your most common one that you will work with is that of water. So first type of phase change unit that you need to know is the heat for the fusion of water. And when I say the fusion of water, I am talking about the phase change of a solid becoming a liquid. Now, essentially what is going on here is that we have ice melting, so solid turning into liquid water. The unit you need to know is that when you are finding this calculation, it is going to be 334.0 joules per gram of water that you have in your sample. And when you are doing a calculation for water and water is being vaporized, it is going from a liquid to a gas, there will be approximately 2,257 joules of energy for every gram of water used. So when we are doing a specific heat calculation and we are going through a phase change, there is a second formula I need for you to know. And it's going to be energy equals mass multiplied by delta H, and delta H will either be your heat of fusion or the heat of vaporization, depending on if you're going from a solid to a liquid or from a liquid to a gas. So we're going to work through just one-step problem first. So I've asked you how much heat is required to turn 215 milliliters of water into steam at 100 degrees Celsius. So we are looking at vaporization here. We are going from liquid water into water gas. And if you remember from last week, we talked about that conversion factor for water for volume to grams. So we're lucky here. If you have 215 milliliters of water, that means we have 215 grams of water as well. And working with that equation, let me get it up here, we have energy equals m delta H. And we are using the m delta H equation because this is a phase change. We're going from liquid water into steam. We're going to plug in our 215 grams of water. And if you look on the previous slide, you will see that your heat value you need to plug in for delta H for vaporization is the 2,257 joules per gram. Now, our gram values are going to cancel out, which will leave us our answer in joules, which makes sense because we are trying to figure out how much energy goes into making water change phases. So when you plug into your calculators 215 times 2,257, that will give you a total of 485,255 joules of energy that was added into that 215 milliliters of water to cause it to go from liquid water all into gas, all into steam. So, another way to look at this is if you are going through multiple phase changes, or if you are just going from liquid water at a lower temperature and raising that temperature to above the point of a phase change. If that is the case, you're going to have to do more than one calculation. So let's look at what we're working with here. We have 250 milliliters of liquid water, and it is at 25 degrees Celsius, so right about room temperature. And we are going to boil this water until that water reaches 150 degrees Celsius. Now, I want you guys to think about this. When water reaches 150 degrees Celsius, is it going to be liquid or is it going to be a gas? It's going to be a gas, right? Because it's at 100 degrees Celsius when we are going to have a phase change. And I don't know what happened there, but there we go. So at 100 degrees Celsius, that water changed phases. It no longer is a liquid. So we are going to have a phase change occurring in the middle of this process. So we first have to do a calculation to figure out how much energy was added to raise the temperature of water from 25 degrees Celsius up to 100 degrees Celsius. And since that is the case, we are just looking at raising the temperature of that water. We're not looking at a phase change yet. We are going to use that original equation we've worked with the past few days, the E equals mc delta T. So we know that we are working with 250 grams of water. We are working with liquid water, which has a specific heat of 4.18. And we are looking at that temperature change up until that water becomes a gas. So we are looking at the temperature change between 100 degrees Celsius and our initial temperature of 25. So when you go through and multiply all of this into your calculator, for this first portion of raising the temperature of water, we had to use 78,375 joules of energy. Now, we had a phase change occur once we reached that 100 degree temperature. So you will have to figure out how much energy did it take to raise the entire 250 milliliters of water to cause all of that water to become steam. So you will have to use your E equals m delta H equation for this to make sense. So we are still working with the same amount of water, 250 grams, but your heat of vaporization for water, that value is the 2,257 joules per gram. When you plug that into your calculator, you will find that in order to cause 250 milliliters of water to become a gas, it took 45,140 joules to do that. That's how much energy you had to add into that water for that phase change to occur. Now, this water didn't stop heating up at 100 degrees Celsius. it increased in temp all the way up to 150 degrees Celsius. It is extremely, extremely hot steam at this point. So you will have to do a third calculation looking at that increase in temperature. There's no phase change happening here. We're just raising the temp of water from 100 to 150 degrees Celsius. And since there's no phase change, you're going to go back to your original equation. No phase change, you will use MC delta T. So we still have 250 grams of water. And since we are working with steam, we need to use the specific heat capacity of steam, which is given to you. It's the 1.996 joules per gram degree Celsius. And our temperature change now is from 150, which is the final temp, from, from the 100 degrees Celsius. So that will give us a total temperature change of 50 degrees. Now, when you multiply all of this into your calculator, you will find that it took 24,950 joules to increase that temperature of water from 100 degrees Celsius to 150. Now, in our problem, we're asked how much heat was required to raise the temperature of water from 25 degrees Celsius to 150. So to find our final answer, we are going to have to total everything together. So we originally raised our temperature of water up until its vaporization point. That took 78,375 joules. We then had to put in 45,140 joules of energy to cause it to vaporize. And then we added an additional 24,950 joules of energy to raise the temperature from 100 to 150 degrees Celsius. So our total of energy that was added is right around 148,465 joules of energy added. So from now on, you guys have to keep track of, is there a phase change happening? Is there not? If there's no phase change happening, awesome. You guys just have to figure out how much energy went into the substance to raise its temperature. If there is a phase change occurring, you will have to use both of these equations. You have to figure out how much energy was added to raise it up to the phase change point, and then how much energy did it take to actually change phases, to go from the solid to a liquid, or a liquid to a gas. Now, to kind of help you to be able to picture this a little bit better, here is your phase diagram, or phase change graph, for water. And to help that previous problem make sense, we started at 25 degrees Celsius. So that water was right around here on your graph. But we need to heat it up to its vaporization point, which is where your graph flattens out. So in order to raise the temperature of your water up to its vaporization point, we had to add in 78,375 joules of energy to cause all 250 grams of water to become steam. We added in the 45,140 joules, and to increase the temperature of that steam, of that water vapor, to right about 150 degrees, we had to add in an additional 24,950. So hopefully this will help you guys to see that to go from 25 degrees Celsius all the way up to 150 we had to put in a lot of energy. That is why you must find that total by adding those three calculations totals together. Now, you guys should have a worksheet where you guys can go through. You can practice this a little bit more. Use your notes, use each other to try to come up with these values for your specific heat capacities. And remember, always ask yourself before you solve the problem, is there a phase change occurring? If so, you have to use the M delta H equation. I'll see you guys on Wednesday.